to the Math Dive in About 5. We are here for third grade multiplication models. I'm Kim.
And I'm Brittany.
Let's get started. So now it's time for you to practice. We're going to have a task that you're going to complete with your team or whoever you're sitting and working with. You're going to think about this word problem and really dive into it and think about it in the way that your students would solve it using manipulatives, models, any kind of strategy that you believe your students would use.
All right, so let's take a look at that task. If you haven't already, pause the video. When you're finished, let's go talk about some of those strategies that you wrote down with your team. If Alex had 6 baskets of apples and each basket has 5 apples in it, think about the ways that we could represent this problem. What would students need to know before solving this problem? What strategies or models do you think your students will use to solve this problem? They might use tools, they might draw a picture, or they might know the fact.
Look at the progression with the new BEST standards. In second grade, students worked a lot with repeated addition and creating arrays and really starting to build those facts, whether they know they're multiplying or not. Now we're just taking it a step further and bringing in the multiplication of 2 whole numbers with products between 0 and 144. This is going to help lay the foundation of multiplication for our students when they start multiplying multi-digit numbers in 4th and 5th grade. So we want to make sure that our students are really getting a strong foundation with those concrete and representational models before we move to the more abstract models and different standard algorithms that we may see in the future.
Introducing multiplication to our students, it's imperative that we start with the concrete phase. We want to start with equal group models and use the equal groups language to describe those models. In the first picture, we can see 5 groups of 4. In the middle picture, we might see 3 rows of 4. We can relate these models to arrays and using terms such as rows and columns in our description. That will help us make that transition to when we start to talk about expressions.
We want to make sure that right away we're not saying 5 times 4 and 3 times 4 because we want our students to understand what times actually means. And by using the groups of and rows of language, this really gets our students in the habit of really understanding what it is that they're learning. Strong foundational understanding of multiplication, we can then draw pictorial representations of the concrete models that we created. So we want to make sure that they're still using those equal groups concepts and language and then just drawing a picture of it. So if you see on the left, we have just 6 circles with 5 in each, and then we have an array to match. When we are using the concrete models to help draw the pictorial representations, we can use plates to represent those different groups, or we could even separate them into groups on the table and just have students use an expo marker to circle the different sets and count the groups that way.
The models you see below are examples of abstract thinking that goes into repeated addition, number lines, and bar models that could become more efficient strategies throughout our students' progression of this benchmark. We want to make sure that our students have a strong foundation with concrete and representational models before making the connection to these abstract models.
So some possible misconceptions that we might see in our classroom when working with bar models is that they might struggle with just seeing that one group as a whole. So if that happens, we can then take snap cubes to create each of those models so they have a one-to-one correspondence and they're able to make that connection between the 5 groups that are in their cube links down to the actual bar model where it's just seen as a numeral value.
Another misconception that your students might have are mislabeling rows and columns and groups. When you're working with those word problems, students may struggle with identifying what information they have and what information they're trying to find. They may be number pluckers and take those 2 numbers that they see and add them when really it might be a multiplication problem. If this happens, we might use numberless word problems to help students understand what's actually happening in that word problem. And then they may take those numbers after they're put in to identify and draw a model of what it actually represents in that word problem. They may label the different parts of the equation to help them organize their information and identify that missing component. Maybe it tells you how many cars there are and how many tires are on each car. So we're able to draw that picture and relate it back to that word problem in order to solve.
Just to summarize the different types of representations that we've seen some concrete models where it was our groups, whether it was shown in a circle or whether it was plates where each group had its own number in it, or if we use colored tiles to create an array. That was our concrete thinking where all of our students should be starting learning multiplication. Then we moved on to representational thinking and drawing pictures of the concrete models that we saw, and then more of the abstract thinking with working with equations, number lines, and bar models. We want to make sure that we're not in a race to get to that abstract thinking. We're really taking the time to lay the foundation in those concrete and representational stages. For our math dive and about 5 for 3rd grade multiplication models. Thank you for tuning in and see you next time.
Bye.